The Science of Human Nature, A Psychology for Beginners, by William Henry Pyle, Professor of Educational Psychology at the University of Missouri, 1917. Read by Psych for Psychology. Author's Preface. This book is written for young students in high schools and normal schools. No knowledge can be of more use to a young person than a knowledge of himself. No study can be more valuable to him than a study of himself. A study of the laws of human behavior, that is the purpose of this book. What is human nature like? Why do we act as we do? How can we make ourselves different? How can we make others different? How can we make ourselves more efficient? How can we make our lives more worthwhile? This book is a manual intended to help young people to obtain such knowledge of human nature as will enable them to answer these questions. I have not attempted to write a complete text on psychology. There are already many such books, and good ones too. I have selected for treatment only such topics as young students can study with interest and profit. I have tried to keep in mind all the time the practical worth of the matters discussed and the ability and experience of the intended readers. To the teacher. This book can be only a guide to you. You are to help your students study human nature. You must, to some extent, be a psychologist yourself before you can teach psychology. You must yourself be a close and scientific student of human nature. Develop in the students the spirit of inquiry and investigation. Teach them to look to their own minds and their neighbors' actions for verification of the statements of the text. Let the students solve by observation and experiment the questions and problems raised in the text and the exercises. The exercises should prove to be the most valuable part of the book. The first 2 chapters are the most difficult but ought to be read before the rest of the book is studied. If you think best, merely read these 2 chapters with the pupils, and after the book is finished come back to them for careful study. In the references, I have given parallel readings, for the most part to Titchener, Pillsbury, and Munsterberg. I have purposely limited the references, partly because a library will not be available to many who may use the book, and partly because the young student is likely to be confused by much reading from different sources before he has worked out some sort of system and a point of view of his own. Only the most capable members of a high school class will be able to profit much from the references given. To the student. You are beginning the study of human nature. You cannot study human nature from a book. You must study yourself and your neighbors. This book may help you to know what to look for and to understand what you find, but it can do little more than this. It is true, this text gives you many facts learned by psychologists, but you must verify the statements, or at least see their significance to you, or they will be of no worth to you. However, the facts considered here, properly understood and assimilated, ought to prove of great value to you. But perhaps of greater value will be the psychological frame of mind or attitude which you should acquire. The psychological attitude is that of seeking to find and understand the causes of human action and the causes, consequences, and significance of the processes of the human mind. If your first course in psychology teaches you to look for these things, gives you some skill in finding them, and in using the knowledge after you have it, your study should be quite worthwhile. Chapter 1. Introduction. Science. Before attempting to define psychology, it will be helpful to make some inquiry into the nature of science in general. Science is knowledge, it is what we know. But mere knowledge is not science. For a bit of knowledge to become a part of science, its relation to other bits of knowledge must be found. In botany, for example, bits of knowledge about plants do not make a science of botany. To have a science of botany, we must not only know about leaves, roots, flowers, seeds, etc., but we must know the relations of these parts and of all the parts of a plant to one another. In other words, in science, we must not only know, we must not only have knowledge, but we must know the significance of the knowledge, must know its meaning. This is only another way of saying that we must have knowledge and know its relation to other knowledge. A scientist is one who has learned to organize his knowledge. The main difference between a scientist and one who is not a scientist is that the scientist sees the significance of facts, while the non-scientific man sees facts as more or less unrelated things. As one comes to hunt for causes and inquire into the significance of things, one becomes a scientist. A thing or an event always points beyond itself to something else. This something else is what goes before it or comes after it, is its cause or its effect. This causal relationship that exists between events enables a scientist to prophesy. By carefully determining what always precedes a certain event, a certain type of happening, a scientist is able to predict the event. All that is necessary to be able to predict an event is to have a clear knowledge of its true causes. Whenever, beyond any doubt, these causes are found to be present, the scientist knows the event will follow. Of course, all that he really knows is that such results have always followed similar causes in the past. But he has come to have faith in the uniformity and regularity of nature. The chemist does not find sulfur or oxygen or any other element acting one way one day under a certain set of conditions, and acting another way the next day under exactly the same conditions. Nor does the physicist find the laws of mechanics holding good one day and not the next. The scientist, therefore, in his thinking brings order out of chaos in the world. If we do not know the causes and relations of things and events, the world seems a very mixed-up, chaotic place where anything and everything is happening. But as we come to know causes and relations, the world turns out to be a very orderly and systematic place. It is a lawful world. It is not a world of chance. Everything is related to everything else. Now, the non-scientific mind sees things as more or less unrelated. The far-reaching causal relations are only imperfectly seen by it, while the scientific mind not only sees things, but inquires into their causes and effects or consequences. The non-scientific man, walking over the top of a mountain and noticing a stone there, is likely to see in it only a stone and think nothing of how it came to be there, but the scientific man sees quite an interesting bit of history in the stone. He reads in the stone that millions of years ago the place where the rock now lies was under the sea. Many marine animals left their remains in the mud underneath the sea. The mud was afterward converted into rock. Later, the shrinking and warping earth crust lifted the rock far above the level of the sea, and it may now be found at the top of the mountain. The one bit of rock tells its story to one who inquires into its causes. The scientific man, then, sees more significance, more meaning in things and events than does the non-scientific man. Each science has its own particular field. Zoology undertakes to answer every reasonable question about animals, botany, about plants, physics, about motion and forces, chemistry, about the composition of matter, astronomy, about the heavenly bodies, etc. The world has many aspects. Each science undertakes to describe and explain some particular aspect. To understand all the aspects of the world, we must study all the sciences. A scientific law. By law, a scientist has reference to uniformities which he notices in things and events. He does not mean that necessities are imposed upon things as civil law is imposed upon man. He means only that in certain well-defined situations certain events always take place, according to all previous observations. The law of falling bodies may be cited as an example. By this law, the physicist means that in observing falling bodies in the past, he has noticed that they fall about 16 feet in the first second and acquire in this time a velocity of 32 feet. He has noted that, taking into account the specific gravity of the object and the resistance of the air, this way of falling holds true of all objects at about the level of the sea. The more we carefully study the events of the world, the more strongly we come to feel that definite causes, under the same circumstances, always produce precisely the same result. The scientist has faith that events will continue to happen during all the future in the same order of cause and effect in which they have been happening during all the past. The astronomer, knowing the relations of the members of the solar system, the sun and planets, can successfully predict the occurrence of lunar and solar eclipses. In other fields, too, the scientist can predict, with as much certainty as does the astronomer, provided his knowledge of the factors concerned is as complete as is the knowledge which the astronomer has of the solar system. Even in the case of human beings, uncertain as their actions seem to be, we can predict their actions when our knowledge of the factors is sufficiently complete. In a great many instances we do make such predictions. For example, if we call a person by name, we expect him to turn or make some other movement in response. Our usual inability to make such predictions in the case of human beings is not because human beings are not subject to the law of cause and effect. It is not that their acts are due to chance, but that the factors involved are usually many, and it is difficult for us to find out all of them. The science of psychology. Now, let us ask, what is the science of psychology? What kind of problems does it try to solve? What aspect of the world has it taken for its field of investigation? We have said that each science undertakes to describe some particular aspect of the world. Human psychology is the science of human nature. But human nature has many aspects. To some extent, our bodies are the subject matter for physiology, anatomy, zoology, physics, and chemistry. Our bodies may be studied in the same way that a rock or a table might be studied, but a human being presents certain problems that a rock or table does not. If we consider the differences between a human being and a table, we shall see at once the special field of psychology. If we stick a pin into a leg of the table, we get no response. If we stick a pin into a leg of a man, we get a characteristic response. The man moves, he cries out. This shows two very great differences between a man and a table. The man is sensitive and has the power of action, the power of moving himself. The table is not sensitive, nor can it move itself. If the pin is thrust into one's own leg, one has pain. Human beings, then, are sensitive, conscious, acting beings. And the study of sensitivity, action, and consciousness is the field of psychology. These three characteristics are not peculiar to man. Many, perhaps all, animals possess them. There is, therefore, an animal psychology as well as human psychology. A study of the human body shows us that the body surface and many parts within the body are filled with sensitive nerve ends. These sensitive nerve ends are the sense organs, and on them the substances and forces of the world are constantly acting. In the sense organs, the nerve ends are so modified or changed as to be affected by some particular kind of force or substance. Vibrations of ether affect the eye. Vibrations of air affect the ear. Liquids and solutions affect the sense of taste. Certain substances affect the sense of smell. Certain organs in the skin are affected by low temperatures, others by high temperatures, others by mechanical pressure. Similarly, each sense organ in the body is affected by a definite kind of force or substance. This affecting of a sense organ is known technically as stimulation, and that which affects the organ is known as the stimulus. Two important consequences ordinarily follow the stimulation of a sense organ. One of these is movement. The purpose of stimulation is to bring about movement. To be alive is to respond to stimulation. When one ceases to respond to stimulation, he is dead. If we are to continue alive, we must constantly adjust ourselves to the forces of the world in which we live. Generally speaking, we may say that every nerve has one end in a sense organ and the other in a muscle. This arrangement of the nerves and muscles shows that man is essentially a sensitive action machine. The problems connected with sensitivity and action and the relation of each to the other constitute a large part of the field of psychology. We said just now that a nerve begins in a sense organ and ends in a muscle. This statement represents the general scheme well enough, but leaves out an important detail. The nerve does not extend directly to a muscle, but ordinarily goes by way of the brain. The brain is merely a great group of nerve cells and fibers which have developed as a central organ where a stimulation may pass from almost any sense organ to almost any muscle. But another importance attaches to the brain. When a sense organ is stimulated, and this stimulation passes on to the brain and agitates a cell or group of cells there, we are conscious. Consciousness shifts and changes with every shift and change of the stimulation. The brain has still another important characteristic. After it has been stimulated through sense organ and nerve, a similar brain activity can be revived later, and this revival is the basis of memory. When the brain is agitated through the medium of a sense organ, we have sensation. When this agitation is revived later, we have a memory idea. A study of consciousness, or mind, the conditions under which it arises, and all the other problems involved, give us the other part of the field of psychology. We are not merely acting beings. We are conscious acting beings. Psychology must study human nature from both points of view. We must study man not only from the outside, that is objectively in the same way that we study a stone or a tree or a frog, but we must study him from the inside or subjectively. It is of importance to know not only how a man acts, but also how he thinks and feels. It must be clear now that human action, human behavior, is the main field of psychology. For, even though our main interests in people were in their minds, we could learn of the minds only through the actions. But our interests in other human beings are not in their minds, but in what they do. It is true that our interest in ourselves is in our minds, and we can know these minds directly, but we cannot know directly the mind of another person. We can only guess what it is from the person's actions. The problems of psychology. Let us now see in some detail what the various problems of psychology are. If we are to understand human nature, we must know something of man's past. We must therefore treat of the origin and development of the human race. The relation of one generation to that preceding and to the one following makes necessary a study of heredity. We must find out how our thoughts, feelings, sensations, and ideas are dependent upon a physical body and its organs. A study of human actions shows that some actions are unlearned while others are learned or acquired. The unlearned acts are known as instincts, and the acquired acts are known as habits. Our psychology must, therefore, treat of instincts and habits. How man gets experience and retains and organizes this experience must be our problem in the chapters on sensations, ideas, memory, and thinking. Individual differences in human capacity make necessary a treatment of the different types and grades of intelligence and the compilation of tests for determining these differences. We must also treat of the application of psychology to those fields where a knowledge of human nature is necessary. Applied psychology. At the beginning of a subject, it is legitimate to inquire concerning the possibility of applying the principles studied to practical uses, and it is very proper to make this inquiry concerning psychology. Psychology, being the science of human nature, ought to be of use in all fields where one needs to know the causes of human action. And psychology is applicable in these fields to the extent that the psychologist is able to work out the laws and principles of human action. In education, for example, we wish to influence children, and we must go to psychology to learn about the nature of children and to find out how we can influence them. Psychology is therefore the basis of the science of education. Since different kinds of work demand, in some cases, different kinds of ability, the psychology of individual differences can be of service in selecting people for special kinds of work. That is to say, we must have some time, if we do not now, a psychology of professions and vocations. Psychological investigations of the reliability of human evidence make the science of service in the courtroom. The study of the laws of attention and interest give us the psychology of advertising. The study of suggestion in abnormal states makes psychology of use in medicine. It may be said, therefore, that psychology, once abstract and unrelated to any practical interests, will become the most useful of all sciences, as it works out its problems and finds the laws of human behavior. At present, the greatest service of psychology is to education. So true is this that a department has grown up called educational psychology, which constitutes at the present time the most important subdivision of psychology. While in this book we treat briefly of the various applications of psychology, we shall have in mind chiefly its application to education. The science of education. Owing to the importance which psychology has in the science of education, it will be well for us to make some inquiry into the nature of education. If the growth, development, and learning of children are all controlled and determined by definite causal factors, then a systematic statement of all these factors would constitute the science of education. In order to see clearly whether there is such a science, or whether there can be, let us inquire more definitely as to the kind of problems a science of education would be expected to solve. There are four main questions which the science of education must solve. 1. What is the aim of education? 2. What is the nature of education? 3. What is the nature of the child? 4. What are the most economical methods of changing the child from what it is into what it ought to be? The first question is a sociological question, and it is not difficult to find the answer. We have but to inquire what the people wish their children to become. There is a pretty general agreement, at least in the same community, that children should be trained in a way that will make them socially efficient. Parents generally wish their children to become honest, truthful, sympathetic, and industrious. It should be the aim of education to accomplish this social ideal. It should be the aim of the home and the school to subject children to such influences as will enable them to make a living when grown and to do their proper share of work for the community and state, working always for better things, and having a sympathetic attitude toward neighbors. Education should also do what it can to make people able to enjoy the world and life to the fullest and highest extent. Some such aim of education as this is held by all our people. The second question is also answered. Psychological analysis reveals the fact that education is a process of becoming adjusted to the world. It is the process of acquiring the habits, knowledge, and ideals suited to the life we are to live. The child in being educated learns what the world is and how to act in it, how to act in all the various situations of life. The third question, concerning the nature of the child, cannot be so briefly answered. In fact, it cannot be fully answered at the present time. We must know what the child's original nature is. This means that we must know the instincts and all the other inherited capacities and tendencies. We must know the laws of building up habits and of acquiring knowledge, the laws of retention, and the laws of attention. These problems constitute the subject matter of educational psychology, and at present can be only partially solved. We have, however, a very respectable body of knowledge in this field, though it is by no means complete. The answer to the fourth question is in part dependent upon the progress in answering the third. Economical methods of training children must be dependent upon the nature of children. But in actual practice, we are trying to find out the best procedure of doing each single thing in schoolwork. We are trying to find out by experimentation the proper way to teach children to read, to spell, to write, etc., must be determined in each case by independent investigation until our knowledge of the child becomes sufficient for us to infer from general laws of procedure what the procedure in a particular case should be. We venture to infer what ought to be done in some cases, but generally we feel insecure till we have proved our inference correct by trying out different methods and measuring the results. Education will not be fully scientific till we have definite knowledge to guide us at every step. What should we teach? When should we teach it? How should we teach it? How poorly we answer these questions at the present time. How inefficient and uneconomical are schools because we cannot fully answer them. But they are answerable. We can answer them in part now, and we know how to find out the answer in full. It is just a matter of patient and extensive investigation. We must say, then, that we have only the beginnings of a science of education. The problems which a science of education must solve are almost wholly psychological problems. They could not be solved till we had a science of psychology. Experimental psychology is but a half-century old, educational psychology, less than a quarter-century old. In the field of education, the science of psychology may expect to make its most important practical contribution. Let us, then, consider very briefly the problems of educational psychology. Educational psychology. Educational psychology is that division of psychology which undertakes to discover those aspects of human nature most closely related to education. These are 1. The original nature of the child, what it is and how it can be modified. 2. The problem of acquiring and organizing experience, habit formation, memory, thinking, and the various factors related to these processes. There are many subordinate problems, such as the problem of individual differences and their bearing on the education of subnormal and supernormal children. Educational psychology is not, then, merely the application of psychology to education. It is a distinct science in itself, and its aim is the solving of those educational problems, which for their solution depend upon a knowledge of the nature of the child. The method of psychology. We have enumerated the various problems of psychology. Now, how are they solved? The method of psychology is the same as that of all other sciences, namely, the method of observation and experiment. We learn human nature by observing how human beings act in all the various circumstances of life. We learn about the human mind by observing our own mind. We learn that we see under certain objective conditions, hear under certain objective conditions, taste, smell, feel cold and warm under certain objective conditions. In the case of ourselves, we can know both our actions and our mind. In the case of others, we can know only their actions, and must infer their mental states from our own in similar circumstances. With certain restrictions and precautions, this inference is legitimate. We said the method of psychology is that of observation and experiment. The experiment is observation still, but observation subjected to exact methodical procedure. In a psychological experiment, we set out to provide the necessary conditions, eliminating some and supplying others according to our object. The experiment has certain advantages. It enables us to isolate the phenomena to be studied. It enables us to vary the circumstances and conditions to suit our purposes. It enables us to repeat the observation as often as we like, and it enables us to measure exactly the factors of the phenomena studied. A psychological experiment. Let us illustrate psychological method by a typical experiment. Suppose we wish to measure the individual differences among the members of a class with respect to a certain ability, namely, the muscular speed of the right hand. Psychological laboratories have delicate apparatus for making such a study. But let us see how we can do it, roughly at least, without any apparatus. Let each member of the class take a sheet of paper and a pencil, and make as many strokes as possible in a half-minute, as shown in Figure I. The instructor can keep the time with a stopwatch, or less accurately with the second hand of an ordinary watch. Before beginning the experiment, the instructor should have each student taking the test try it for a second or two. This is to make sure that all understand what they are to do. When the instructor is sure that all understand, he should have the students hold their pencils in readiness above the paper, and at the signal, begin, All should start at the same time and make as many marks as possible in the half minute. The strokes can then be counted and the individual scores recorded. The experiment should be repeated several times, say 6 or 8, and the average score for each individual recorded. Whether the result in such a performance as this varies from day to day and is accidental, or whether it is constant and fundamental, can be determined by repeating the experiment from day to day. This repetition will also show whether improvement comes from practice. If it is decided to repeat the experiment in order to study these factors, constancy, and the effects of practice, some method of studying and interpreting the results must be found. Elaborate methods of doing this are known to psychologists, but the beginner must use a simpler method. When the experiment is performed for the first time, the students can be ranked with reference to their abilities, the fastest one being called first, the second highest, second, and so on down to the slowest performer. Then, after the experiment has been performed the second time, the students can be again ranked. A rough comparison can then be made as follows. Determine how many who were in the best half in the first experiment are among the best half in the second experiment. If most who were among the best half the first time are among the best half in the second experiment, constancy in this performance is indicated. Or we might determine how many change their ranks and how much they change. Suppose there are 30 in the class and only 4 improve their ranks, and these to the extent of only 2 places each. This would indicate a high degree of constancy. 2 different performances can be compared as above described. The abilities on successive days can be determined by taking the average rank of the first day and comparing it with the average rank of the second day. If the effects of practice are to be studied, the experiments must be kept up for many days, and each student's work on the first day compared with his work on succeeding days. Then a graph can be plotted to show the improvement from day to day. The average daily speed of the class can be taken and a graph made to show the improvement of the class as a whole. This might be plotted in black ink, then each individual student could put on his improvement in red ink for comparison. A group of 30 may be considered as furnishing a fair average or norm in this kind of performance. In connection with this simple performance, making marks as fast as possible, it is evident that many problems arise. It would take several months to solve anything like all of them. It might be interesting, for example, to determine whether one's speed in writing is related to this simple speed in marking. Each member of the class might submit a plan for making such a study. The foregoing simple study illustrates the procedure of psychology in all experimentation. A psychological experiment is an attempt to find out the truth in regard to some aspect of human nature. In finding out this truth, we must throw about the experiment all possible safeguards. Every source of error must be discovered and eliminated. In the above experiment, for example, the work must be done at the same time of day, or else we must prove that doing it at different times of day makes no difference. Nothing must be taken for granted, and nothing must be assumed. Psychology, then, is like all the other sciences, in that its method of getting its facts is by observation and experiment. Summary. Science is systematic, related knowledge. Each science has a particular field which it attempts to explore and describe. The field of psychology is the study of sensitivity, action, and consciousness, or briefly, human behavior. Its main problems are development, heredity, instincts, habits, sensation, memory, thinking, and individual differences. Its method is observation and experiment, the same as in all other sciences. Class exercises. Make out a list of things about human nature which you would like to know. Paste your list in the front of this book, and as you find your questions answered in this book, or in other books which you may read, check them off. At the end of the course, note how many remain unanswered. Find out whether those not answered can be answered at the present time. Does everything you do have a cause? What kind of cause? Human nature is shown in human action. Human action consists in muscular contraction. What makes a muscle contract? Plan and experiment, the object of which shall be to learn something about yourself. Enumerate the professions and occupations in which a knowledge of some aspect of human nature would be valuable. State in what way it would be valuable. Make a list of facts concerning a child which a teacher ought to know. Make a complete outline of Chapter 1. References for class reading. Munsterberg, Psychology, General and Applied, Chapters 1, 2, and 3. Pillsbury, Essentials of Psychology, Chapter 1. Pyle, The Outlines of Educational Psychology, Chapter 1. Heckner, A Beginner's Psychology, Chapter 1. Chapter 2. Development of the Race and of the Individual. Racial Development. The purpose of this chapter is to make some inquiry concerning the origin of the race and of the individual. In doing this, it is necessary for us first of all to fix in our minds the idea of causality. According to the view of all modern science, everything has a cause. Nothing is uncaused. One event is the result of other previous events, and is in turn the cause of other events that follow. Yesterday flowed into today, and today flows into tomorrow. The world as it exists today is the result of the world as it existed yesterday. This is true not only of the inorganic world, the world of physics and chemistry, but it is true of living things as well. The animals and plants that exist today are the descendants of others that lived before. There is probably an unbroken line of descent from the first life that existed on the earth to the living forms of today. Not only does the law of causality hold true in the case of our bodies, but of our minds as well. Our minds have doubtless developed from simpler minds, just as our bodies have developed from simpler bodies. That different grades and types of minds are to be found among the various classes of animals now upon the earth, no one can doubt, for the different forms certainly show different degrees of mentality. According to the evidence of those scientists who have studied the remains of animals found in the Earth's crust, there is a gradual development of animal forms shown in successive epochs. In the very oldest parts of the Earth's crust, the remains of animal life found are very simple. In later formations, the remains show an animal life more complex. The highest forms of animals, the mammals, are found only in the more recent formations. The remains of man are found only in the latest formations. Putting these two facts together, one, that the higher types of mind are found today only in the higher types of animals, and two, that a gradual development of animal forms is shown by the remains in the Earth's crust, the conclusion is forced upon us that mind has passed through many stages of development from the appearance of life upon the earth to the present time. Among the lower forms of animals today, one sees evidence of very simple minds. In amoebas, worms, insects, and fishes, mind is very simple. In birds, it is higher. In mammals, it is higher still. Among the highest mammals below man, we see manifestations of mind somewhat like our own. These grades of mentality shown in the animals of today represent the steps in the development of mind in the animals of the past. We cannot here go into the proof of the doctrine of development. For this proof, the reader must be referred to zoology. One further point, however, may be noted. If it is difficult for the reader to conceive of the development of mind on the earth similar to the development of animals in the past, let him think of the development of mind in the individual. There can certainly be no doubt of the development of mind in an individual human being. The infant, when born, shows little manifestation of mentality, but as its body grows, its mind develops, becoming more and more complex as the individual grows to maturity. The world as dynamic. The view of the world outlined above and held by all scientific men of the present time may be termed the dynamic view. Man formerly looked upon the world as static, a world where everything was fixed and final. Each thing existed in itself and for itself, and in large measure independent of all other things. We now look upon things and events as related and dependent. Each thing is dependent upon others, related to others. Man not only lives in such a world, but is part of such a world. In this world of constant and ceaseless change, man is most sensitive and responsive. Everything may affect him. To all of the constant changes about him, he must adjust himself. He is being produced by this world, and to live in it, he must meet its every condition and change. We must, then, look upon human nature as something coming out of the past and as being influenced every moment by the things and forces of the present. Man is not an independent being unaffected by everything that happens. On the contrary, he is affected by all influences that act upon him. Among these influences may be mentioned weather, climate, food, and social forces. The condition of the various organs of a child's body determine, to some extent, the effect which these various forces have upon it. If a child's eyes are in any way defective, making vision poor, this tremendously influences his life. Not only is such a child unable to see the world as it really is, but the eye strain resulting from poor vision has serious effects on the child, producing all sorts of disorders. If a child cannot hear well, or is entirely deaf, many serious consequences follow. In fact, every condition or characteristic of a child that is in any way abnormal may lead on to other conditions and characteristics, often of a serious nature. The growth of adenoids, for example, may lead to a serious impairment of the mind. Poor vision may affect the whole life and character of the individual. The influence of a parent, teacher, or friend may determine the interest of a child and affect his whole life. The correct view of child life is that the child is affected, in greater or less degree, by every influence which acts upon him. Significance of development and causality. What are the consequences of the view just set forth? What is the significance of the facts that have been enumerated? It is of great consequence to our thinking when we come to recognize fully the idea of causality. We then fully accept the fact that man's body and mind are part of a causal and orderly world. Let us consider, for example, the movement of a muscle. Every such movement must be caused. The physiologist has discovered what this cause is. Ordinarily and normally, a muscle contracts only when stimulated by a nerve current. Tiny nerve fibrils penetrate every muscle, ending in the muscle fibers. The nerve impulse passing into the fibers of the muscles causes them to contract. The nerve stimulus itself has a cause. It ordinarily arises directly or indirectly from the stimulation of a sense organ. And the sense organs are stimulated by outside influences, as was explained previously. Not only are our movements caused, but our sensations, our ideas, and our feelings follow upon, or are dependent upon some definite bodily state or condition. The moment that we recognize this, we see that our sensations, ideas, and feelings are subject to control. It is only because our minds are in a world of causality and subject to its laws that education is possible. We can bring causes to bear upon a child and change the child. It is possible to build up ideas, ideals, and habits. And ideas, ideals, and habits constitute the man. Training is possible only because a child is a being that can be influenced. What any child will be when grown depends upon what kind of child it was at the beginning and upon the influences that affect it during its early life, while it is growing into maturity. We need have no doubt about the outcome of any particular child if we know, with some degree of completeness, the two sets of factors that determine his life, his inheritance, and the forces that affect this inheritance. We can predict the future of a child to the extent that we know and understand the forces that will be effective in his life. The notion of causality puts new meaning into our view of the training of a child. The doctrine of development puts new meaning into our notion of the nature of a child. We can understand man only when we view him genetically, that is, in the light of his origin. We can understand a child only in the light of what his ancestors have been. As these lines are being written, the greatest, the bloodiest war of history is in progress. Men are killing men by thousands and hundreds of thousands. How can we explain such actions? Observation of children shows that they are selfish, envious, and quarrelsome. They will fight and steal until they are taught not to do such things. How can we understand this? There is no way of understanding such actions until we come to see that the children and men of today are such as they are because of their ancestors. It has been only a few generations, relatively speaking, since our ancestors were naked savages, killing their enemies and eating their enemies' bodies. The civilized life of our ancestors covers a period of only a few hundred years. The pre-civilized life of our ancestors goes back probably thousands and thousands of years. In the relatively short period of civilization, our real original nature has been little changed, perhaps none at all. The modern man is, at heart, the same old man of the woods. The improvements of civilization form what is called a social heritage, which must be impressed upon the original nature of each individual in order to have any effect. Every child has to learn to speak, to write, to dress, to eat with knife and fork. He must learn the various social customs and to act morally as older people dictate. The child is by nature bad, in the sense that the nature which he inherits from the past fits him better for the original kind of life which man used to live than it does for the kind of life which we are trying to live now. This view makes us see that training a child is, in a very true sense, making him over again. The child must be trained to subdue and control his original impulses. Habits and ideals that will be suitable for life in civilized society must be built up. The doctrine of the Bible in regard to the original nature of man being sinful and the necessity of regeneration is fundamentally correct. But this regeneration is not so much a sudden process as it is the result of long and patient building up of habits and ideals. One should not despair of this view of child life. Neither should one use it as an excuse for being bad or for neglecting the training of children. On the contrary, taking the genetic view of childhood should give us certain advantages. It makes us see more clearly the necessity of training. Every child must be trained, or he will remain very much a savage. In the absence of training, all children are much alike and all alike bad from our present point of view. The chief differences in children in politeness and manners generally, in morals, in industry, etc., are due, in the main, to differences in training. It is a great help merely to know how difficult the task of training is, and that training there must be if we are to have a civilized child. We must take thought and plan for the education and training of our children. The task of education is in part one of changing human nature. This is no light task. It is one that requires, in the case of each child, some 20 years of hard, patient, persistent work. Individual development. Heredity is a corollary of evolution. Individual development is intimately related to racial development. Indeed, racial development would be impossible without heredity in the individual. The individual must carry on and transmit what the race hands down to him. This will be evident when we explain what heredity means. By heredity, we mean the likeness between parent and offspring. This likeness is a matter of form and structure, as well as lightness of action or response. Animals and plants are like the parents in form and structure, and to a certain extent their responses are alike when the individuals are placed in the same situation. A robin is like the parent robins in size, shape, and color. It also hops like the parent birds, sings as they do, feeds as they do, builds a similar nest, etc. But the likeness in action is dependent upon likeness in structure. The young robin acts as does the old robin, because the nervous mechanism is the same, and therefore a similar stimulus brings about a similar response. Most of the scientific work in heredity has been done in the study of the transmission of physical characteristics. The main facts of heredity are evident to everybody, but not many people realize how far-reaching is the principle of resemblance between parent and offspring. From horses, we raise horses. From cows, we raise cows. The children of human beings are human. Not only is this true, but the offspring of horses are of the same stock as the parents. Not only are the colts of the same stock as the parents, but they resemble the parents in small details. This is also true of human beings. We expect a child to be not only of the same race as the parents, but to have family resemblances to the parents, the same color of hair, the same shape of head, the same kind of nose, the same color of eyes, and to have such resemblances as moles in the same places on the skin, etc. A very little investigation reveals likenesses between parent and offspring which we may not have expected before. However, if we start out to hunt for facts of heredity, we shall perhaps be as much impressed by differences between parent and child as we shall by the resemblances. In the first place, every child has two parents, and it is often impossible to resemble both. One cannot, for example, be both short and tall. One cannot be both fair and dark. One cannot be both slender and heavy. One cannot have both brown eyes and blue. In some cases, the child resembles one parent and not the other. In other cases, the child looks somewhat like both parents, but not exactly like either. If one parent is white and the other black, the child is neither as white as the one parent nor as black as the other. The parents of a child are themselves different, but there are 4 grandparents, and each of them different from the others. There are 8 great-grandparents, and all of them different. If we go back only 7 generations, covering a period of perhaps only 150 years, we have 128 ancestors. If we go back 10 generations, we have over 1,000 ancestors in our line of descent. Each of these people was, in some measure, different from the others. Our inheritance comes from all of them, and from each of them. How do all of these diverse characteristics work out in the child? In the first place, it seems evident that we do not inherit our bodies as wholes, but in parts or units. We may think of the human race as a whole being made up of a great number of unique characters. No one person possesses all of them. Every person is lacking in some of them. His neighbor may be lacking in quite different ones. Now, one parent transmits to the child a certain combination of unit characters, the other parent a different combination. These characteristics may not all appear in the child, but all are transmitted through it to the next generation, and they are transmitted purely. By being transmitted purely, we mean that the characteristic does not seem to lose its identity and disappear in fusions or mixtures. The essential point in this doctrine of heredity is known as Mendelism. It is the principle of inheritance through the pure transmission of unit characters. An illustration will probably make the Mendelian principle clear. Let us select our illustration from the plant world. It is found that if white and yellow corn are crossed, all the corn the first year, resulting from this crossing will be yellow. Now, if this hybrid yellow corn is planted the second year and freely cross-fertilized, it turns out that 1/4 of it will be white and 3/4 yellow. But this yellow consists of 3 parts, one part being pure yellow which will breed true, producing nothing but yellow. The other 2 parts transmit white and yellow in equal ratio. That is to say, these 2 parts are hybrids, the result of crossing white with yellow. It is not meant that one can actually distinguish these 2 kinds of yellow, the pure yellow and the hybrid yellow, but the results from planting it show that 1/3 of the yellow is pure, and that the other 2/3 transmit white and yellow in equal ratio. The main point to notice in all this is that when 2 individuals having diverse characteristics are crossed, the characteristics do not fuse and disappear ultimately, but that the 2 characteristics are transmitted in equal ratio, and each will appear in succeeding generations, and will appear pure, just as if it had not been crossed with something different. The first offspring resulting from the cross, known as hybrids, may show either one or the other of the diverse characteristics, or, when such a thing is possible, even a blending of the two characteristics. But whatever the actual appearance of the first generation of offspring resulting from crossing parents having diverse characteristics, their germ cells transmit the diverse characteristics in equal proportion, as explained above. When one of the diverse characteristics appears in the first generation of offspring and the other does not appear, or is not apparent, the one that appears is said to be dominant, while the one not appearing is said to be recessive. In our example of the yellow and white corn, yellow is dominant and white recessive. And it must be remembered that the white corn that appears in the second generation will breed true just as if it had never been crossed with the yellow corn. 1/3 of the yellow of the second generation would also breed true if it could be separated from the other 2/3. It is not here claimed that Mendelism is a universal principle, that all characteristics are transmitted in this way. However, the results of the numerous experiments in heredity lead one to expect this to be the case. Most of the experiments have been with lower animals and with plants, but recent experiments and statistical studies show that Mendelism is an important factor in human heredity, in such characteristics as color of hair and eyes and skin, partial color blindness, defects of eye, ear, and other important organs. The studies that have been made of human heredity have been, for the most part, studies of the transmission of physical characteristics. Very little has been done that bears directly upon the transmission of mental characteristics. But our knowledge of the dependence of mind upon body should prepare us to infer mental heredity from physical heredity. Such studies as throw light on the question bear us out in making such an inference. The studies that have been more directly concerned with mental heredity are those dealing with the resemblances of twins, studies of heredity in royalty, studies of the inheritance of genius, and studies of the transmission of mental defects and defects of sense organs. The results of all these studies indicate the inheritance of mental characteristics in the same way that physical characteristics are transmitted. Not only are human mental characteristics transmitted from parent to offspring, but they seem to be transmitted in Mendelian fashion. Feeble-mindedness, for example, seems to be a Mendelian character and recessive. From the studies that have been made, it seems that two congenitally feeble-minded parents will have only feeble-minded children. Feeble-mindedness acts in heredity, as does the white corn in the example given above. If one parent only is feeble-minded, the other being normal, all of the children will be normal, just as all of the corn, in the first generation after the crossing, was yellow. But these children whose parents are the one normal and the other feeble-minded, while themselves normal, transmit feeble-mindedness in equal ratio with normality. It works out as follows. If a feeble-minded person marry a person of sound mind and sound stock, the children will all be of sound, normal mind. If these children take as husbands and wives men and women who had for parents one normal and one feeble-minded person, their children will be 1/4 feeble-minded and 3/4 of them normal. To summarize the various conditions, if a feeble-minded person marry a feeble-minded person, all the children will be feeble-minded. If a feeble-minded person marry a sound, normal person, pure stock, all the children will be normal. If the children, in the last case, marry others like themselves as to origin, 1/4 of their offspring will be feeble-minded. If such hybrid children marry feeble-minded persons, 1/2 of the offspring will be feeble-minded. It is rash to prophesy, but future studies of heredity may show that Mendelism, or some modification of the principle, always holds true of mind as well as of body. Little can be said about the transmission of particular definite mental traits, such as the various aspects of memory, association, attention, temperament, etc. Before we can speak with any certainty here, we must make very careful experimental studies of these mental traits in parents and offspring. No such work has been done. All we have at the present time is the result of general observation. Improvement of the race. Eugenics is the science of improvement of the human race by breeding. While we can train children and thereby make them much better than they would be without such training, this training does not improve the stock. The improvement of the stock can be accomplished only through breeding from the best and preventing the poor stock from leaving offspring. This is a well-known principle in the breeding of domestic animals. It is doubtless just as true in the case of human beings. The hygienic and scientific rearing of children is good for the children and makes their lives better, but probably does not affect their offspring. We should not forget that all the social and educational influences die with the generation that receives them. They must be impressed by training on the next generation, or that generation will receive no influence from them. The characters which we acquire in our lifetime seem not to be transmitted to our children, except through what is known as social heredity, which is merely the taking on of characteristics through imitation. Our children must go through all the labor of learning to read, write, spell, add, multiply, subtract, and divide, which we went through. Moral traits, manners and customs, and other habits and ideals of social importance must be acquired by each successive generation. Heredity versus environment. The question is often asked whether heredity or the influence of environment has the most to do with the final outcome of one's life. It is a rather useless question to ask, for what a human being or anything else in the world does depends upon what it is itself and what the things and forces are that act upon it. Heredity sets a limitation for us, fixes the possibilities. The circumstances of life determine what we will do with our inherited abilities and characteristics. Hereditary influences incline us to be tall or short, fat or lean, light or dark. The characteristics of our memory, association, imagination, our learning capacity, etc., are determined by heredity. Of course, how far these various aspects develop is to some extent dependent upon the favorable or unfavorable influences of the environment. What is possible for us to do is settled by heredity. What we may actually do, what we may have the opportunity to do, is largely a matter of the circumstances of life. In certain parts of New England, the number of men who become famous in art, science, or literature is very great compared to the number in some other parts of our country. As far as we have any evidence, the native stocks are the same in the two cases, but in New England, the influences turn men into the direction of science, art, and literature. Everything there is favorable. In other parts of the country, the influences turn men into other spheres of activity. They become large landowners, then of business and affairs. The question may be asked whether genius makes its way to the front in spite of unfavorable circumstances. Sometimes it doubtless does. But pugnacity and perseverance are not necessarily connected with intellectual genius. Genius may be as likely to be timid as belligerent. Therefore, unfavorable circumstances may crush many a genius. The public schools ought to be on the watch for genius in any and all kinds of work. When a genius is found, proper training ought to be provided to develop this genius for the good of society as well as for the good of the individual himself. A few children show ability in drawing and painting, others in music, others in mechanical invention, some in literary construction. When it is found that this ability is undoubtedly a native gift and not a passing whim, special opportunity should be provided for its development and training. It will be better for the general welfare, as well as for individual happiness, if each does in life that for which he is by nature best fitted. For most of us, however, there is not much difference in our abilities. We can do one thing as well as we can many other things. But in a few there are undoubted special native gifts. Summary. This is an orderly world in which everything has a cause. All events are connected in a chain of causes and effects. Human beings live in this world of natural law and are subject to it. Human life is completely within this world of law and order and is a part of it. Education is possible only because we can change human beings by having influences act upon them. Individuals receive their original traits from their ancestors, probably as parts or units. Mendelism is the doctrine of the pure transmission of unit characters. Eugenics is the science of improving the human race by selective breeding. An individual's life is the result of the interaction of his hereditary characteristics and his environment. Class exercises. Try to find rock containing the remains of animals. You can get information on such matters from a textbook on geology. Read in a geology about the different geological epochs in the history of the Earth. Make a comparison of the length of infancy in the lower animals and in man. What is the significance of what you find? What advantage does it give man? What is natural selection? How does it lead to change in animals? Does natural selection still operate among human beings? See a modern textbook on zoology. By observation and from consulting a zoology, learn about the different classes of animal forms, from low forms to high forms. By studying domestic animals, see what you can learn about heredity. Enumerate all the points that you find bearing upon heredity. In a similar way, make a study of heredity in your family. Consider such characteristics as height, weight, shape of head, shape of nose, hair, and eye color. Can you find any evidence of the inheritance of mental traits? Make a complete outline of Chapter 2. References for class reading. Davenport, Heredity in Relation to Eugenics. Callicott, The Social Direction of Human Evolution. This has been Part 1 of Psych for Psychology's audio reading of The Science of Human Nature, A Psychology for Beginners by William Henry Pyle.